Welcome everybody to another tutorial. My name is Seth. I am in Desga, and today I'm hoping this will be quick, swift. I'm hoping it will give the information that people will need. But today I'm going to be teaching you how to do a basic sort of 3D view in GameMaker, sort of like the foundation for you to build some knowledge upon and for you to learn and grow. Disclaimer: this is for people who do have some level of knowledge of how GML works, how GMS2 works. So this isn't for beginners, but if you are a beginner, feel free to just try to absorb as much as you can, and if you have any questions, put it in the comment section below. I will try to answer them. If you happen to see a comment that you can answer, feel free to answer that. But yeah, this is what we're going to do today. As you can see, this is a 3D view. It's got a spinning axis and it's got a texture that is aligned to the origin of the view, and it's all rotating. And this is all in GameMaker. And I'm going to teach you exactly how to do this, and I'm hoping it's useful. So we're going to have to set up some variables to get everything going. The first few variables, or functions actually, that we need is to set the speed of the game in the room, and to reset the display, and to set z test enable equals 1. So you're just going to type game set speed, set it to a really big number. This is just to make it so, because if you have no cap, but then you turn on VSync in the display reset, it will cap to the maximum frames per second that your screen can display. If you happen to want it to lock it at 60, obviously just change this to 60, that's fine. For example, my screen is 120 Hz, so because since GameMaker runs each tick, the amount of times that the game speed is, there's no delta timing here, right? Obviously you want to make sure that things are consistent, but for something like this, which there's no timers, there's nothing that's tick orientated, then we can just sort of make it uncapped. We're going to use actual timers, like real-world timers, to make things rotate, so it's going to be okay. And then we have GPU set Z test enable. This is important. You have to turn this on, because when things are being drawn onto the screen, you have to actually test if there's actually like a pixel that's above it because of the depth where it's projected onto the screen. So if you don't have that, things will be drawn in the order that they're drawn rather than the order in which the depth is. You'll see. Now, we have the cam X, cam Y, and cam Z positions. These are the positions in which the camera is, and then we have the look X, look Y, and look Z positions, which is where the camera is looking. So we have like a position where it is and position where it's looking, and we have to basically create a matrix to go, oh, this is exactly how the 3D world is created. These are your variables. Now get all the information, draw it, and put it onto the screen. That's basically what we're trying to do here. Now the next few bits is we have some reset matrices. These are useful for like if you were to do some calculations in the draw GUI event, or in the draw event itself. Basically, this just sets all the matrices to the defaults. There are some other ways to do this. You can, as I said, as it's written here, you can do a build identity, but this, just for the amount of times that I've done like 3D experiments, I've found that I've always wanted to like have the default, and it's good to not create the matrix every single tick. It's good to just have it set, and you can just grab it whenever you want. So highly recommend having that just for the future. And then we have the actual matrices function variables that we have here that we're going to be changing and inserting into the actual particular matrix bits that's going to be part of the whole entire 3D system. So we can go 0, 0, and the matrix world is actually not gonna be affected in this particular scenario, but if we were to have something that is to animate or to move or to change shape, we will have to change a matrix world. But for this particular instance, we are going to keep it completely just sort of default. So if you're doing this with me, go ahead and pause the video if you want. You can look at the variables. I was going to type these out live. I know that a lot of tutorials do that, But I figured this is going to be a little bit more of a fail-safe way, just to make sure that you know exactly the order in which things go. It's easier for me, so I don't have to worry that I'm getting it wrong. But yeah, so take a moment, get all the variables down here. I'll scroll up a little bit so you can see, and we'll continue with the next bit. Okay, so this next bit is in the step event. So all you have to do is make sure that you create a step event. And this is when we're going to actually have to set the matrices that affect the view and how everything is drawn. So we're going to first do the matrix view. We're going to go matrix build lookat. Now that is the function that allows us to create the actual matrix that allows us to go, oh, this is the camera, and we're going to actually this is the thing that's gonna be collecting all the information. That's the best way that I sort of see it. I know that this is probably a more exact way of describing it, but that's the way that I see it. These two variables, we need to have cam x and cam y in the create event, as you can see here, x and y. Now that's only if you want it to be static. These are actually to do the spinning animation, because we have length direction x, length direction y. And the direction is just current time, which is just, it's just a variable that is getting bigger, and we can use that to basically create a circle, and we have the x and y. So if we just had x, it would just sort of go back and forth. We have the x and y, so it allows us to go around the point. The z is set, that's always going to be 8. But the actual, the initial position of the camera is going to be going around the origin, but the look position, as you can see here, is 0, 0, and 4. The look position is looking at the origin, the center. And so it means that when we're going around, it's like we're doing this. We're looking at the point, and we're sort of moving around, and we're looking at just that one position. If we sort of flip those around, it means that we would have something more like an FPS camera. So you would have one fixed position, but then the look at position would change and allow you to sort of look around and move, but the starting position would be stationary, or stationary in relation to the way that you're looking. So then there are these three little variables we have to put in here. Now this is the x up, y up, and z up. This is to give GameMaker sort of like, oh, which direction is up, which way, which is sort of like the orientation in which the camera is there. I personally prefer Z to be positive up. That works the best in my brain. If you think about the way that actually, you know what? I'm gonna draw it on Photoshop. Okay, so basically we have the origin here, which is the 0, 0 position in which everything is built. We're going to have Z as positive, so Z is positive going up. If you think of it like the sea level, when you measure something, it goes, you're going up. You know, you're 6 feet tall. You're not negative 6 feet tall, right? So positive going up, and then I mean the X and Y doesn't really matter because you can have positive or negative. It's just a 2D plane, right? Now, the matrix view is the actual camera itself. It's like we're creating the camera. It's like creating the head, where we're going, oh, I'm here and I'm looking there, and my head is orientated this way or that way, or you know, in this case we're orientated this way because Z is up. Now, matrix projection is like, how do we look at things? Are we looking at things with no depth or warp? Are we looking at things with no perspective? Is there no field of view? And we're gonna specify sort of like the range, how close or far things are, and that's what we have to also create. Now, the matrix world is something that I mentioned before. The matrix world is used for kind of like transforming things, because when you submit a vertex, it goes through the matrix world and it goes, well, I'm in this world. If you change that world, it would sort of change the way that the vertex is created. So if you go matrix world with a scale of 2 in the x-axis, when you submit some vertices, some shapes, it would go, oh, but these shapes are in this different world, or the original world, that just so happens to have a 2x scale on the x-axis, and it warps everything. So this can be used for animations, it can be used for particular scenarios where we want to scale things. It's not overly efficient to constantly change the matrix world, but at times when you maybe you're not very familiar with shaders, it's very useful. Okay, so as you can see, we just completed the matrix view, and now we have the matrix projection that I talked about, the perspective, how we're gonna look at things. Very simple. It's a function called matrix build projection perspective field of view. There's lots of different other versions. You can actually go matrix build. I zoomed in slightly. There we go. Matrix build, and you can have a look. There's orthographic, which basically means that there's no warping. A cube will sort of look the same. There's no perspective. Then there is perspective, but you can specify a width or height in which you're looking at. And then there's a field of view, which allows you to give a point, but then the field of view specifies how much you're looking at and how much range, the angle in which the range is capturing the world. So we're using a field of view because we're gonna just most situations field of view is the normal way of doing it. And we're going to make it 90, which is also a very normal sort of field of view. It's 90 degrees. It allows you to sort of see. It's not exactly full peripheral vision, but it means that you don't have too much warping. If you're familiar with Minecraft, you got that slider. That's what we're changing. And the ratio is, we have to specify the ratio in which it's drawing to. If we make it a square, but the actual real view is not a square, it will be warped. So we need to make sure the ratio is exactly the same. So you have to make sure that you're basically getting the ratio of your window, right? And now in here is the Z near. Just make it 0.01. It could be anything that's like very close to 0. Don't make it 0, but it can be 0.01 or just 0.1. Now the far. This specifies sort of how far away the Z buffer goes. So if we have a Z buffer of 16, right? Anything that goes further than 16 will literally disappear. And you got to have a big number, but there are certain times where, especially if you're using shaders, you don't want it to be too big. So in this particular case, I got 20,000. But you could honestly get away, especially depending on your size and stuff, you could get away with something like 1,000, or even less, right? Also depends on if you have fog and etc., etc. But that's it for that, and that sets the matrices. We don't need to set the world because that is unchanging, and we're good to go for that bit. Next bit. Okay, so here's the next bit. We need to, this is the draw event. Again, just go into the events. By the way, this is, as I said at the start of the video, this is assuming that you know how to work GameMaker. I'm not going to walk through every single individual step. I can just assume that you can look at it, and this is sort of like looking at a tutorial on a forum, but with actually me talking and describing how things work, since I think that, for me, it definitely helps a lot. So here we're just going to clear a few things. This line actually we don't really need, but this means that if you don't have a background, or you just want to clear, it's good practice, just sort of clear the surface before you draw things. It doesn't cost much. It's a very cheap function. I go 0, 0. You can go 0, 1 if you want to be actual solid black, but this is to clear it to make sure that you don't have any smudging of textures. There's no refreshes. We're going to set the color, set the alpha, just as you should in the draw event. And then now we have the 3 matrices sets. We kind of don't need to set the world. As I said before, the world is unchanging. At the start here, we have matrix build identity. That is actually the same as the reset world. So we kind of don't need to have this line, but at times where maybe you alter something later on, it's good to reset the world, because maybe you change the world and then you forget to change it back, and then it draws completely out of scale and you're like, whoa, what the heck just happened? You need to make sure that the matrix world stays the same before and after of everything. You can't just change it. As in, if I was to change the matrix world at the end of this line but then draw something afterwards, it will completely warp it. So yes, And as I said here, we've got matrix set, so you want to write matrix underscore view, and then mat view, matrix underscore projection, and then mat projection. Those are the two that we just created. So we're setting the camera, we're setting the projection, and we've got the world. And then now you can see these functions here, and you're like, oh, but we haven't made any vertices yet. This is kind of the complicated bit, and I'm going to do my best to explain how this works. But first, we've got a model axis, which is with a line list, and then we also have a model block. We don't really need the text repeat, but we do have the block, do have the axis, and I'm gonna show you. I'm gonna show you how to create these. Okay, so in the create event, below all that we had here, we're gonna be creating these models. Now, there are numerous ways you can do this, and I highly, highly, highly recommend creating some scripts. So we're actually going to take all of this, and we're going to turn it into some scripts. So I'm actually going to be refactoring while explaining how to do this. So we need to set up, essentially need to set up two things before you actually start creating the model. The first one is the format, as you can see here, and the second one is the actual buffer itself. Now, when you create a vertex buffer, the model itself you can't edit afterwards. There are ways you can go around it by creating a buffer and then recreating that into the vertex buffer and then editing it, but then complicated. But in this particular case, we're doing it very simply. We just want to create the vertex buffer, and then we want to submit it, and then we want to see it. And that's all we want to do. So in this particular case, we're creating a format. Now, what is a model format, or in this particular case, a vertex format? I like to think of it as a model format. It makes sort of more sense in my head because I call 3D things models. You have when you're submitting vertices to GameMaker and through the particular matrix views, projections, and worlds, it reads things in a very specific order. You can't just be like, oh, I have these positions and these colors, and it's like, how does it know which color goes to which position? So you give it a format. It goes color position, color position, color position, color position, and knows which one is associated to which, right? So that's what we're doing here. So we're going to go vertex format begin, and then we're going to go vertex format add position 3D. So we're going to add a format, a bit to the list, right? A 3D position, and then we're going to add a color. So that means that with every vertex, it has, oh, I have a position and I have a color. It's simple. This is purely for drawing lines and wireframes and things that don't have textures or colors or textures or anything complicated. You can do flat colors as well, but I tend to use it for drawing lines and things like that. So I call that model format, and capitals because I think it's easier to look at capital, especially if it's like an important thing like a format that doesn't change. I tend to make it capitals. You can do it in other ways. You can use enums and globals and stuff like that, but I just do capitals. It's fine. And the other model format we have here is the texture UV format. So it's exactly the same, 3D color, see 3D color, but then now we have text coord. Now, text coord is two variables, is the U and the V. So we have the X text coord and the Y text coord. Now, the way that it works is that if you go 0, 0, it will grab the first position of whatever texture at the top left-hand corner. If you go 1, 0, it goes to the very end of the texture. It's not in pixels. This is something that younger me didn't know, and I discovered it the hard way. It's not in pixels. It's 0 to 1. And that means that if you're wanting things that are very specific width in a particular texture, you have to basically divide it out in a range of 0 to 1. And we'll see this in a second. So here's the model axis. This is the actual axis that is being created, and we essentially need to. We're gonna factorize this. We're gonna make it a little bit nicer. So let's create some scripts, and I'll describe how this works. So first script, we're gonna go we're going to go Vertex Line. Okay? Vertex Line. Now, it's a bit of a jump, but Vertex Line is super useful because it means that you can just put in an X and a Y, an X and a Y, or XYZ, XYZ, and it will just do it for you. You don't have to write, especially if the color is the same. But essentially, it's this. We're going to go argument 0. Whoops. And we're going to chuck that in. So that's essentially we're going to be inserting. We're going to go, oh, that is the model axis. And then we have the X, Y, Z positions. So we're going to go argument 1, 2, 3, and 2. And then we're going to go, if you want it to be different colors, I'm going to make it so the lines are all one color. So in this particular case, the color is going to be at the end. So we're going to go 2, 3, 4, 5, 6, and then this one, the actual color, because I don't really bother with alpha, is 7. Done. Script done. So now this can be replaced with Vertex Line, and we want to go model axis, and we want the, I'll just type it out, the XY, first XYZ position, so 16, 0, 0, and then the other XYZ position, minus 16, 0, 0, and then the color. So we want to go 0, 0, 0, FF, which is red. So it's blue, green, red. And that's it. And that basically replaces all of that. Done with one line. This is why scripts are important. Now, you need to, this axis model, the reason why I have 16, completely arbitrary. It could be any size that you want. I'm just doing 16 because it's just a number I tend to use. You can use 100, 1,000, doesn't matter. Just anything. But what we're doing, right, is on the X, these are X coordinates. We're going positive 16 on the X, and then negative 16 on the X. And it's just an X, it's just a line. We're drawing the X axis. That's it. And you can see that we have that on the other ones too. So we have it on the Y, and then we have it on the Z. So we can essentially just copy this, right? And I can delete this because it's very easy to understand. You have the X, Y, Z. X, Y, Z color. So we're going to move this to 16. Actually, you know what? Let's type this out from the start. So 0, so 16, 0, 0, minus 16, 0. And then we're going to have a particular color, 0, 0, FF, 0, 0, so we're going to have green. And this one, 0, 0, 16, 0, 0, minus 16. And then another color. Done. And that's going to be drawing the X, the Y, and the Z. Easy schmeezy. Now, actually, you know what? Let's just comment that out for now. So now I'm hoping if you're following with me, you would have done that. We want to at the very end go model axis, vertex end model axis, and then vertex freeze. That just makes it efficient. It just means you can't edit it or do anything with it, and it makes it a lot more efficient. Passes through and submits a lot faster. And once you do that, we're good to go. So we can actually, like, if you type in vertex submit model axis, comma primitives, so PR underscore line list, and then -1 because there's no texture, and make sure in your room you actually place the object, and that's it. Done. How cool is that? Ta-da! You just made a spinning axis. I'm hoping that blew your mind a little bit. Maybe you did, maybe it didn't. I don't know. But we're not going to stop there because I'm hoping to help you a little bit with the UVs. So let's get into that. Okay. So this is the texture sheet for our blocks. I highly recommend that you make a texture sheet that is a square number. Like, don't... I was doing some experimenting before, and I made it so the texture sheet was only the three blocks wide and only 1 block high. And it caused a lot of issues because it seems that that when it comes to UV is you really have to make sure that it's a square number, or else it calculates kind of weirdly. So in this particular case, make sure the image is a square, even if you don't use all the space, and make sure that it's an even number of the tiles of which you're choosing, or it doesn't have like an odd number size. It's 2, 4, 8, 16, 32, 64, 128, 256, etc. In this particular case, mine is 64 by 64, my tiles are 16 by 16, probably look familiar, kind of Minecrafty, doesn't matter. We're going to have the first one, second one, the third one. We're only going to be drawing the first one. So, you need to make sure in your sprite, you need to make sure you turn on edge filtering, pre-multiply alpha, and a separate texture page. This prevents anything from changing the way that it's being drawn. You don't want there to be any weird alpha issues. And the reason why you want a separate texture page is because if you don't, it will crop, and the way that it kind of figures out the texel position will get all messed up. So that's definitely important. And now we can hop back into here, and this is where we can start to unwrap how things work. So as I said, you got to specify a block size. My block size is 16 by 16. You don't really have to do that, but sometimes it's good to do this to sort of understand the way that UVs work. So we have the width. So if we go back to this, we have the width, 64, and we divide it by the block size. So divide by 16, which will be 4, right? So that means there's 1, 2, 3, 4 on the X. And same with the Y, 1, 2, 3, 4. But that's gonna only give 4. That's not exactly the UV position we want. We want the width divided by 4. And since it's only from 0 to 1, we go 1 divided by that number. If we had a texture sheet that had like 1,000 blocks in one direction, 1,000 blocks in the other direction, then obviously we'll go the width divided by the block size, and then 1 divided by that. And the result, if for the first one, will probably be something like 0.0001 or something very small. In this particular case, since it's 1 divided by 4, it's 0.25. So this position here, right? This position here is 0, and this position here is 0.25. This is 0.5, and this is 0.75. That's how we specify where everything is. And same with the Y. 0, 0.25, 0.5, da 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 da. So now back in here, you will see this in the code. Sprite get width, that's this sprite here. That divided by the block size, so 64 divided by 16, which is 4, and then 1 divided by that. That is the texel X. I highly recommend calling it that. It's a good way to remind yourself that a texel position is inside the texture because it's only from 0 to 1. Same with the Y, we can use that to literally specify whole blocks. We don't have to write 0.25 every time. We literally just go the whole texel, and then we can actually move that around if we were going to be changing it anyway. Now, this is where things get a little more complicated. You can see there's a lot happening here. We have the position, color, texture, position, color, texture, position, color, texture. There's 3 chunks. Now, the reason why is because when we're creating models, you can the maximum way in GameMaker you can create a model is a triangle. You can't really create a square with lines. Really, you can make it with triangles. So you have to specify the actual triangle itself, and you have to create it. You have to do one triangle, and you have to do the other triangle. So let me quickly draw in Photoshop, and I'll show you. Basically, when we're drawing a particular, let's say we want to draw a square, right? In the 3D world, let's say we're looking down at it. We can't just be like, oh yeah, this is 1 point, 1 point, 1 point, 1 point. That's not going to work. GameMaker works in triangles. So we're gonna, the best way to think about it, definitely, is to go clockwise, and we're gonna go this position, this position, this position, and that'll create a triangle. And then we go this position, let's use a different color, this position, this position, this position, and then I'm gonna create another triangle. And these 2 triangles combined creates the square. Now this does get a little complicated, especially when you have, actually I'll draw it, especially when you have one that's on the floor, and then you have one that's on the wall, and then you have another one that's on the wall, and another one, and then you have one that's on the top, and trying to figure out like where those points are can get a little messy, but it does just take a moment to think about, oh, where are these positions? Where are these points going in the triangle, right? But we're going to do just a flat plane, just to get your head around it, and I'll show you how to do that. So as you can see, put my pen down, as you can see, we have the first position, second position, third position. Now, what we're going to do, since this is possibly the best way to do it, we're going to go Vertex Plane. Alright, just like we did Vertex Line, we're going to create a plane, which is basically just a square, but it could be any size, so we call it plane. I'm going to create a new script, Vertex Plane, and this is essentially where we're going to have all of this, right? Okay, so let me break it down. First position, actually with all of this, let's just go argument 0. Let me model block like that. Cool. So this is where, so I'm drawing things with the origin being the center of the square, right? We're not going 0, 0 and then going across. We're actually going -8, -8, and then +8, and it's sort of going with the origin in the center. So so you knew what it looked like at the start of this video. So I'm actually, for the sake of this, I'm actually going to make it so the origin is the top left. But if you want to move it, we can actually, you know what? I will add a translate bit to the function to allow us to move. So let's add some variables here. So we first have the model type. That's all good. And we're gonna go variable. Let's go x, and you want to go argument 1, and we're gonna go y is argument 2, and z is argument 3. Cool. And now we also want to get the width and height, but I think in this particular case it's going to be fixed, so we'll just go 16 and it'll be okay. And what else do we want? I think that's about it. We do have in here the texel x, texel y. I'm actually it's gonna be okay because the variables are set here, so as long as we run this code in this object, it'll be fine. So that's all good. We can go like block type, and then we can basically go texel x plus texel x times the particular ID of which block we want. But we'll stick with the grass, so it'll just be 1 for this particular case. So we want to go x, y, and z. And we want to basically have these inside the positions, and we'll edit the positions from there, right? So if you want to program with me, type in vertex position 3D. We're gonna have the argument 1, the x, y, z, and this is the top left, right? Top left, easy peasy. Then we have the vertex color. That's just going to be white because the texture is white. So, or texture, if you change this, it's going to change the blend mode of the texture, is basically what that does. And then we have the text coord, which is, as I mentioned, the texel position, in this case, 0, 0, because it's the top left. Now, the next one is that we're going to be going across, since we're going clockwise, right, as you saw. So we're going to go x plus 16, because this is the in-world position, right? We're going to go x plus 16. This could technically be anything, because the texture will scale to it, but, you know. And then we have the block texel x. That's a whole texel across in the x position. Now we want to go to the bottom right, so we're going to go plus 16 on the x and plus 16 on the y, and then we have texel x and texel y. So that goes that position, that position, that position, dun dun dun, and it'll create a triangle. Now actually we can test this totally. We can absolutely comment that out. We can go back to here, and we can actually run it, and it will work. So Okay, I realized it didn't work because I actually forgot to put in the model block. So this is where we can change the position, right? So -8, 0, so that's moving it into the center. And now it should work. I'm an idiot. No, we have yet to actually submit the vertex. So in the draw event, you want to go vertex submit model block PR triangle list, and then you want to go sprite get texture of that block and the first sub image. And now it will work. Huzzah! Look at that! So that's the first triangle. We have the top left, the top right, and then the bottom right, and then now we have to do the other triangle to fill in that gap, because we only have that particular slice of the texel. So let's do the rest. Okay, so in this code, we basically have a very similar situation. We're gonna go the same, because we're starting at the same position, but now we're gonna be going to the bottom left as well. So top left, that's easy, X, Y, Z, same color, 0, 0 for the text coord. But then now we're gonna go to the bottom right. So we're gonna go +16, +16, and then we're gonna have the texel X, texel Y, since that's down at the bottom right. And then now we're going to the other triangle. So we wanna go here, the X doesn't plus anything, but the Y is +16. There's no texel X, so we're gonna go 0, and then texel Y. And then, huzzah, now, theoretically, ta-da! It works. It works wonderfully. And this concludes the tutorial. Okay, so while I was editing, I realized that my camera just didn't want to work for that particular scene. But I decided I'll insert this little bit and give my outro. Thank you everyone for watching. If you have any questions, feel free to just put them down below. And as I said before at the start, if you see some questions you can just answer them for me. We're all sort of in this together. Just spread the knowledge. If you have any tips that maybe I didn't cover in this video, definitely put them down below. Leave a like if you enjoyed this, and make sure you subscribe as well. I'm hoping to put some more videos out at some point. But yeah, I thank you very much, and I will see you hopefully in the next one. I also stream very often, so make sure you subscribe to or follow my stream, twitch.tv/ndesga. There will be a link below. I stream relatively often. I do a lot of NiCoreDev 3D stuff, Awesome, sweet, great, have a great day. I'll see you later. Bye.